Hello, and thank you for joining us today for our webinar on the industry's latest trends presented by Contech. Before we start today's presentation, we would like to cover a few housekeeping matters that will ensure we have a smooth presentation. We have placed all phones on mute to cut down on background noise and to ensure everyone can hear the presentation. At the conclusion of today's webinar, we will provide information on how to obtain PDH certificates for today's presentation. The webinar is scheduled to last 1 hour. We will have about 50 minutes of presentation followed by a question and answer period. When you logged on to the webinar, the Go to Webinar window will have appeared on the upper right-hand corner of your screen. This window will minimize it by itself after a few minutes so that it does not interfere with your viewing the webinar. If you would like to maximize this window, just click on the small red arrow and the window will be maximized. The blue box in the Go to Webinar window will allow you to minimize or maximize the presentation so you can view it in whatever size works best for you. If you have questions, please type your question into the question box. We will be taking questions throughout the webinar. Presenting today will be Scott Aston. Scott is the Vice President of Structures for Contech. Also presenting today will be Tim Kilty. Tim is the Area Vice President for Contech's Eastern Region. He has over 20 years experience in the precast concrete industry. Now I'd like to turn it over to Scott.
Thank you very much, Lisa. As Lisa indicated, you'll be hearing from Tim Kilty and I throughout the presentation today. And we are both from Contech. If you're not familiar with Contech, Contech is an engineered site solutions provider. The schematic that's on the screen gives you a little bit of a representation of the types of solutions that we offer. They range from bridge to drainage to erosion control, retaining walls, stormwater, wastewater treatment. Not only are we a solutions provider, but we also aim to be your project partner, meaning we want to work with you and collaborate with you throughout all aspects of project lifecycle. Our goal really today, though, is to educate and provide information on Contech's newest bridge innovations, and we're going to do that here in just a couple of moments. I do think it's important that you know that this webinar format and presenting information in this way is something that we view as being very valuable and a way to help us communicate with the engineering community in an effective manner. We also think it's very important that we convey this information live and we have a conversation with you. So today is December the 4th. We're going to be delivering 2 webinars today, one this morning and one this afternoon. In those 2 sessions, we'll have well over 1,000 people that are learning about the information that we have here today. I'm very excited, though, before Tim and I get into the meat of the presentation about the innovations, to introduce to you Mike Colmo. Mike is a partner with CME and has 29 years of experience in bridge and highway design. He has special expertise in the field of accelerated bridge construction technologies and is the author of the FHWA's Accelerated Bridge Construction Manual. We're very happy to have him here today, and he has some exciting information that he's going to share with you about the Accelerated Bridge program. So, Mike?
Thanks, Scott. The goal of my presentation here today is to give an overview of accelerated construction technologies and how it fits in with the Contech products that you're going to learn about in this webinar. All the Contech products that are available are prefabricated products, and prefabrication is a large part of the accelerated construction industry that is existing in the United States right now. I'll be talking about Contech products in addition to other precast, prefabricated products, but they all fit in together. For instance, on the first screen here, you see a precast pier. That could be used with some of the Contech superstructure products that are out there. Bear with me a second as my screen advances. There we go. There are several available documents that are available online for accelerated construction technologies. The Federal Highway Administration has been a very big supporter of accelerated construction and prefabrication. The first document that is available currently is the Connection Details Manual. If you go on Federal Highway, if you go on Google and type in FHWA Connection Details, it'll bring you to a website where you can download this document for free. It's a document that contains approximately 150 details that have been used around the country for prefabricated projects using accelerated construction. Included in this manual are several details for Contech products. The second document that's available is an accelerated construction manual. This manual was produced in 2011. If you go on Google and type in FHWA space ABC, it'll bring you to a website where you can download this manual as well. This is an overall overview manual that covers all different types of ABC technologies, a lot of what I'll be talking about today. Coming in the near future are two more manuals covering accelerated construction and prefabrication. The first one covers contracting and construction for ABC projects, and the last one is a manual on design, engineering, design, fabrication, and erection of prefabricated elements. These two documents should be available shortly in the next 6 months or so. They'll also be available for free downloads through Federal Highway. This is the basis of what I'm presenting today. And so if you don't get all the notes today, you can download these documents and get more information. Now, first question is, what is ABC? And this is a definition that I put together. It's essentially using innovative planning, design, and construction methods in a safe and cost-effective manner to reduce project delivery time and on-site construction time. Pretty basic definition. The key thing is we're looking at both project delivery time and on-site time to reduce the overall delivery of projects. Federal Highway and AASHTO have been working with accelerated construction for many years. This is not new. It really started out initially with the AASHTO Technology Implementation Group, which is a group of people who look at bringing new technologies into the market. And this is a quote from an early website saying we need to change the way we build our highways and bridges. And we coined the phrase get in, get out, and stay out, meaning start the construction and finish as fast as possible, and then use high-quality products to make sure they last long so we don't have to come back. ABC, many of you have probably seen these kind of slides before, but we'll try to reiterate some of the benefits of ABC. Obviously, reducing on-site construction time is a big portion of this. We're trying to reduce mobility impacts to travelers. That's a very costly thing when we keep people stuck in traffic for construction projects. Also, we can reduce environmental impacts by getting in and out faster. The user cost, we're going to minimize delays to travelers, which result in cost to them. But I put in red here, the second to the last bullet, improving safety is a big issue with ABC. We can reduce the amount of time we're in the field constructing a bridge. We're reducing the amount of time construction workers and travelers are exposed to difficult and sometimes complex traffic management setups. And lastly, quality is improved with prefabricated products. Federal Highway has had several programs that dealt with ABC. The first was the Highways for Life program, and you can see the acronym spelled out there where we're looking at innovation in fast construction. This program will be sunset. It was sunset with the last transportation bill. However, the technology has been picked up in the new transportation bill with the Everyday Count initiative, where prefabrication and ABC are a big part of the EDC technology group. The goal of the EDC is to reduce project delivery time by 50%, and that is both design development and construction. The EDC program has come up with what they call an ABC toolbox, and it covers these technologies. Today I'll be speaking mostly about the center box, which is prefabricated bridge elements and systems, where we prefabricate pieces off-site and bring them together on-site to build the bridge rapidly. Why should we care about ABC? This question comes up a lot. Many projects, at least the early ABC projects, do cost somewhat more than conventional construction, although those costs can be offset by agency savings in reduced construction management time and traffic control time and things like flagging costs. But in general, bid prices are a little higher with ABC, so why should we consider it? And this is a poll data from Utah DOT. They did a poll of some of the recent ABC projects, and the first question they asked is whether or not people understood what ABC was, and you can see 93% did know, which means that Utah DOT was doing a good job with their public outreach. But the second question was very interesting, where the question asked, knowing that ABC reduces traffic congestion and road closures, but increased cost, do you favor or oppose you not using ABC? And the answer here, you look at it, 59% strongly favor and 32% somewhat favor the approach. So the general conclusion here is that the traveling public, they're not as concerned with cost as they are concerned with congestion and impacts due to construction projects. And this is something we all need to keep in mind, is that the end users of all of our work are the travelers, and we need to keep that in mind when we make our project decisions. Prefabrication, all parts of bridges can be prefabricated. I just have a few slides showing some of the technologies that are out there today. Precast decks are very common in the United States. used on precast concrete girders, as well as precast decks on steel girders, shown here. The abutments shown in these sketches are also can be made with precast concrete. Here's a photograph showing a precast deck being built in New Hampshire. Very common products that are out there for deck replacements. In addition, all other parts of the structure can be built, including piers. This is an exploded view of a precast concrete pier. The next slide shows an X-ray view showing some of the couplers that are used to connect these products together. And essentially building these things, we sometimes refer to these bridges as Lego bridges for obvious reasons, and where we can actually join pieces together rather quickly in the field and construct the bridge rapidly. Abutments are also made with precast concrete. Integral abutments are very common and very popular in the United States. There is a great technology out there that was developed in a few different states using corrugated metal pipes cast into concrete elements to connect integral abutments to piles. And you simply slide the element over the piles, insert concrete in the void, and you have a connection made very rapidly. This is a photograph of a bridge in Massachusetts being built with that technology. One thing you'll note in this photo, there are 3 voids in each piece that are put down, and there's only 2 piles shown. The third hole is literally put in the piece just to reduce the shipping and handling weight of the piece. Little trick that we do to reduce costs for cranes and shipping. More photos of substructures. These are wall structures, either cantilever wall structures or cantilever abutments. Again, voids are used to reduce the weight of the elements so we can have larger elements and smaller cranes. Just a flavor of some of the technologies that are out there that are included in some of these manuals that I mentioned before. Now we get into some of the products that Contech manufactures, and you'll learn more about this in the rest of the presentation. But precast arch structures are very common around the country. A great example of prefabricated elements. You'll learn today about the precast footing that Contech has developed with a very innovative design. So again, the products that we're going to be talking about today are prefabricated elements that can reduce construction time significantly. So they definitely fit into the category of accelerated construction. In addition, Contech makes prefabricated superstructures, and as I said before, you can place these superstructures on precast substructures that we showed in the previous slides. So all this fits together, and it gives you a toolbox of options for building bridges more quickly. So in conclusion, ABC is gaining momentum. We're seeing a large number, the majority of the states in the United States are starting some form of an ABC program. User satisfaction really is the driving factor that we should be considering because they are the ultimate benefactors of the work. Federal Highway has been a great motivator pushing this technology forward, and now we're seeing many states stepping forward to become leaders in ABC. So the key thing, the last most important thing, is that technology is here and market ready. This is not research laboratory work. There are literally hundreds of projects being built every year now with accelerated construction. So with all these tools and these Federal Highway manuals, you can go a long way to building ABC into your next project. With that, that concludes my presentation.
Thank you very much, Mike. I think we can all appreciate that Mike has consolidated a very complex topic into a handful of slides, and really could do an all-day webinar just on accelerated bridge construction and the technologies. But I think you did a great job giving us an overview and understanding what's happening in the market. Also did a nice job of beginning to introduce the rest of the presentation, which is how Contech dovetails with a lot of what is taking place in the FHWA and the Accelerated Bridge Program. Our goal today, again, is not to give you a complete overview of our bridge structures, but I do think it's important to understand a little bit of the entire range of solutions. At Contech, we separate those solutions into 3 major categories or buckets, that being plate, precast, and truss. If you're not familiar with plate, they're corrugated metal plates bolted together into various shapes to achieve either full invert solutions or 3-sided solutions. The precast arch solutions we'll be talking a lot about in this presentation. And then we also have both pedestrian and vehicular truss solutions. You can see there from the years of experience and the number of installations that Contech is not new to this. Contech is the industry leader in all of these categories, and we have a lot of installations to show for it, and we've collaborated with engineers on an incredible number of these installations. But the real focus of today's presentation is on a couple of the items that you see on this page, specifically bridge core and O series, and then the express foundations, and giving you just a little bit more information on those innovations specifically. Some of you may have participated in or may have remembered receiving an invite from us about this time last year. It was actually in November of last year that we introduced these technologies to the engineering community through a webinar very similar to what we're doing today. And the goal of today is to give you a little bit of an update on those, but also or a reminder of what was covered in that webinar, but also an update on some of the new things that are happening and just how far things have come in that past year. I know being in the civil engineering industry, all of you can appreciate that new technologies oftentimes take many years or decades in order to be accepted into the design community and being integrated into designs. I think because of the unique nature of what we've been able to do here, we've just seen an overwhelming response and adoption rate amongst engineers. And you can see that depicted by this slide and the number of dots. Those dots represent projects or bridges in which these new technologies have been integrated. The blue ones represent installed projects. The red represent pending installations that should happen in the next 90 days or so. If you think about multiple years out, we have literally thousands of projects that we're working with engineers on with these new technologies that you're about to see. But just the dots on the map there represent upwards of 150 individual projects. So the response has been overwhelming, and I think the success and what's happened on these individual projects, which you will see, has also been overwhelming. Now we know that the number of dots on this map is not only reflective of the technologies themselves, but it's also reflective of the market conditions. And so at least at Contech, what we've been beginning to see is an uptick in some of the design of projects, a little bit of an uptick in the market conditions, and things improving certainly over where they were a year or two or three ago. And I know that discussion about the market and what's happening is something that's close to all of our hearts, and we're curious to see what all of you might be thinking or hearing in your areas, and I think you could all appreciate hearing from your colleagues that are on the phone here with us today. So what we'd like to do is introduce the first of what we call a poll question or a participant poll, in which it gives you the opportunity to actually click on the screen and weigh in and provide your input on what's happening in your area. So Lisa, would you mind guiding us through the first one of those?
Thanks, Scott. Ladies and gentlemen, on your screen you should notice a poll coming up. Which way do you see the markets turning in your area? Markets are up, markets are flat, markets are down. We just want to get everybody's perspective on this, share with your colleagues, so please go ahead and vote. Also, we are taking some questions, so don't forget to log those into the question box. We will try to get to them at the end. Thank you for your time. We have a few more votes coming in. I'll leave this open for a few more seconds. All right, I'm going to go ahead and close the poll and share the results. Scott, the results are in. Markets are up. 55% of the audience has indicated that. 42% have said they are flat, and only 4% have said they are down.
That's very encouraging, Lisa, and certainly matches with what we're seeing here at Contech, and certainly much different than when we asked a similar question a year ago, and we look forward to seeing how that translates to future designs for all of us here upcoming. So with that, I'd like to turn the presentation now over to Tim Kilty, who's going to run through some of these new innovations in a little more detail. Go ahead, Tim.
Hey, thanks, Scott. Thanks, Lisa. Yeah, it's good to see those statistics because we are seeing the markets up, certainly flat in some areas, but by and large we're seeing some real growth. And as Scott demonstrated on that national graphic, the embracing that we've seen from the industry as it relates to these innovations has been overwhelming, and it's pretty exciting. So we'll start with the Conspan O series. I noticed some of the registrations, and I recognized some names, and there were some new names on there, so it's exciting to see some new folks being able to dial in and giving us the opportunity to share these new innovations. So the first one we'll talk about is the Conspan O series, and the O series is the most efficient three-sided structure in the industry today. It features almost a 20% concrete reduction over the original Conspan shape and almost a 40% reduction over your traditional three-sided flat top. Now, a little bit of housekeeping as it relates to the O series. Usually the question comes up when we do these webinars is what's going to happen to the original Conspan shape? It will remain in our portfolio. We certainly see there might be a place in grade separations, that type of thing, where the original Conspan shape may come into play. But by and large, you know, what we've seen over the last year, from a hydraulic standpoint, from a wetland standpoint, and just from an efficiency standpoint. The O Series is really the platform that we have moved to from an engineering support standpoint, and this is the system that we're moving forward with. And it's certainly been validated from the industry. So quick question would be, why have we changed? Why have we optimized? If you think about Contech, you know, we've really been the leader in three-sided structures for many, many years, so why would you change anything? The ConSpan system itself has been designed by, specified, and installed by more DOTs than any other three-sided structure in the country. It really is the most successful brand name in the industry. So why change? Well, I think you really have to understand Contech's history of innovation to answer that question. I've got a timeline there on the screen for everybody to see, and it goes from the 80s until today, and it really should go from the 60s until today. Because if you think back in 1960, the original BEBO arch, precast BEBO arch was developed, and then in the 1970s, the three-sided flat top evolved, and both of those were very good structures on their own. One of them obviously had some hydraulic efficiency as it related to the box, and then we had the structural capacity of the arch. But in the 80s, those two systems were blended to result in a ConSpan, the original shape ConSpan, which was an arch box shape. But Contech didn't really stop there. In 1989, we developed precast head walls and precast wing walls for a total set-in-place precast structure, which has really been the gold standard for end treatments in the market today. From 1995 to 2005, spans went from 36 feet to 60 feet. Throughout the 90s, the Army Corps of Engineers felt like the utilization of this product was such that it incorporated ConSpan in name and by name in the HECRAS hydraulic modeling program. So throughout this entire history, the engineers at Contech have spent a lot of time trying to find better, more efficient ways to build these structures, resulting in less concrete and more efficient steel cross-sections. Hence, the O Series. So now, as the name would imply, the shape has been optimized to increase the span and waterway over the original ConSpan shape. Now, just a quick bit of clarification. Today we're going to talk about the arch. The end treatments, by and large, the head walls and the wing walls have not changed. Those will remain the same. You will still have a total set-in-place precast structure, but the innovative piece of the bridge has been the arch itself. So if you look at this drawing, you can see that this basic arch top has been retained. And what we've done is we've manipulated these legs outward. And that simple manipulation, it's going to mobilize more of this arch action than the original ConSpan shape, thus reducing the stress on this haunch, resulting in thinner concrete sections and significantly less steel. So I think this animation really tells the story. You can see as we rotate those legs outward, the stress in the haunch is reduced, and that results in significantly reduced concrete and steel areas. So you can see here, this concrete section is going to kind of thin out here, and then this is a pretty heavy area of steel in the original shape, and when we reduce the stress on that haunch, that steel area has been significantly reduced. The moment diagram probably tells the best story. If you think about a flat top or even the original ConSpan shape, this is a pretty inefficient turn. The red is obviously the ConSpan original shape moment diagram, and the blue represents the O Series. And the O Series really behaves like more of an arch. So you can see when we rotate these legs outward, our maximum positive and negative moments have been significantly reduced. Just to sort of close out this whole loop on evolution, you know, again, if you think about the 60s, the precast arch was developed, and then in the 70s, the three-sided flat top was developed. You know, what this was really good at from a hydraulic standpoint, this structure not so much, and kind of vice versa. And so in the 80s, the ConSpan B series, if you will, or B is for basic, if I didn't already mention that, was developed, which was really a good blend of that hydraulic efficiency and structural capacity. And today, we have the best blend of the hydraulic efficiency and the structural capacity. And the reason I take you through that whole timeline is because I think a few slides ago I said this simple manipulation or this simple rotation of these legs, it may have been simple, but it's taken us almost 30 years to get here. So we're really excited, and certainly the industry has embraced this system as a whole, and we see a lot of possibilities for the industry on a go forward. Where do you use these structures? The same places that you've used bottomless structures in the past, whether it be wetlands, hydraulics, clearance box, grade separations, etc. Use these structures in those same applications, just more efficiently. And as I mentioned, as it relates to grade separation, those projects can get a little bit challenging, and so we would look at everything in our portfolio, whether it be the old B series, the Conspan O series, or the BEBO arch. Quick design examples to show you some of the savings associated with this system. I've got two of them here. One's going to be a wetlands crossing, one's going to be hydraulic. So let's start with the wetlands. The goal here is to span a creek, and the span required is 25 feet. Rise is not a big issue. This is a wetlands crossing, so we've got room to work with anywhere from 4 foot to 10 foot max, and the structure length is 24 feet. Okay? So for the O series, we would look at what we call as a O425, or a 25-foot span, versus the original Conspan shape would be a 28-foot span. So you might be looking at your screen saying, well, that doesn't seem like a very even or fair comparison, a 25-footer versus a 28-footer. We did this on purpose because this is a great time to point out that our spans go from 12, our O series spans go from 12 to 65 feet in 1 foot increments. This is a big change over the original B series. The B series was all in 4 foot increments. It's the way they were designed, the way they were analyzed, the way the equipment was built. Now we have the opportunity. We've seen over the last 10 years the real drivers is the span, and these 1 foot increments is really important to have in the industry. So if you need a 25-foot span, you use a 25-foot span. So moving on down the page here to look at some of the savings. You'd look at a 5-foot rise versus a 6-foot rise, but here's where it starts to jump off the page. You'd be looking at 1.96 tons of concrete versus 2.84 for a 31% savings and almost a 50% savings in steel area. The other piece of this example that sort of gets overlooked is the number of pieces. Because the O series, because we reduced the concrete in the O series, it's much lighter. So we can build these in longer lay lengths. So whereas a B series would only be a 6-foot lay length, the O series would be an 8-foot lay length. So you reduced a truck, you reduced the amount of pieces you have to set in the field, you reduced the amount of time that your crew's out there setting the units. Again, those aren't big savings, but incrementally they all add up to some savings for the project. Okay, so let's switch over to a hydraulic crossing. Same thing here, we're looking for a 25-foot span, but now we have a waterway area of 190 square feet that we're working with and a structure length of 72 feet. So as is the case for the O series, we'd be looking at an O27 versus the B series, which is a 28-foot span. So those are pretty close there. Then we come down here to concrete savings. We're about 22% savings in concrete and almost 40% savings in steel. And again, I said sometimes the lay lengths get overlooked. The longer the structure gets with these longer lay lengths, the more savings there can be. And in this case, this is a 72-foot long structure. So now we only have 9 trucks versus 12 trucks. If anybody's familiar with transportation, it's pretty significant in the precast industry. And then again, the amount of sets that you have and the duration that the crew is going to be out there on the job site. So those were a couple of quick examples. What we'd like to do now is we've seen a growth of this product, and we've got some ongoing innovations that have been a result of the O series, and Scott's going to share some information on that.
Sure, Tim. As we said, it's been about a year since these technologies were introduced. In that time, we've participated in a number of projects and learned a number of things. We've also learned quite a bit from the engineers that have worked on those projects. You've provided us feedback that has helped us learn. As a result, our research and development team has been working on a number of items, and we'd like to give you a little bit of a taste of some of those things in the next couple of slides. One thing that may seem obvious is we do multiple cell structures regularly. Here's an example of a multiple cell O series structure. It's primarily hydraulically driven. It's at the JBLM project at Army and Air Force Base in Washington State. And what we have seen, though, is on projects similar to this, you can see based on the configuration of those legs coming down at the center pier, some feedback from engineers has been, hey, we'd like to add a little hydraulic efficiency there. Maybe the entrance coefficient as flows come into the structure could be a bit improved. So while we see this type of solution on the screen being used very regularly, and I think it will continue to be used, we've developed some different options or alternatives to improve those flow characteristics entering the structure. And that's a multiple cell O-series option that has a vertical center wall. So it should be pretty obvious there in the graphic at the top of the page. That vertical center wall eliminates that triangular shape and improves flows coming into the structure. Additionally, we get into cells beyond 2 cells very regularly. Could be 3, could be 4, could be 5. You can see those ability to provide those vertical center walls with a variety of different cells going across the structure. All of this is designed to improve hydraulics, and just a little twist on our O-series design that's come from feedback from you that we think could be designed into many projects in the future. In fact, we have a number of them being designed now, and we anticipate our first installation of one of these types of structures here any day now. Another item that's important to note about the ongoing development is that I guess it's human nature, but for whatever reason when we first introduce these structures to any engineer for the first time, the question that always comes up is, how big can you go? Everyone wants to know the limitations in terms of the span range. As Tim indicated a few moments ago, the span range for O-Series ranges from 12 to 65 feet in every 1 foot increment. There's a lot of benefits to those 1 foot increment. I have put up a couple of photographs of a 65 foot O-Series just so we can all kind of grasp the magnitude and the size of a structure that large. And this one is in Livingston Parish, Louisiana. Now, the design principles, the economies, the optimization that Tim talked about really extends indefinitely. It certainly extends beyond 65 feet. But the 65-foot limitation comes from more of a practical limitation, that being it needs to be manufactured, it needs to be lifted up at the manufacturing facility, placed on a truck down the road, lifted off of that truck, and placed into place on a job site. From a practical standpoint, it's very difficult to ship or manufacture anything larger than 65 feet. But given that there's a need for longer spans and that the optimization and the efficiency extends beyond 65 feet, we are actively exploring and working on projects in a twin leaf configuration to go beyond 65 feet. If you don't know what I mean by twin leaf, it just simply means that the structure arrives in 2 pieces and then is put together with a crown joint at the top. That crown joint has exposed reinforcing steel that then gets filled in with structural concrete such that the arch acts as one continuous unit once it's in place on the job site. Now you might also be thinking to yourself, if you're familiar with Contec's portfolio of products, well, doesn't the BEBO already extend beyond 65 feet? Why would you need something different? I just wanted to give you a little bit of a rundown of a couple of the BEBO solutions and where we see those being limited for use on some projects. The BEBO shape goes out to 102 feet in its longest size. In this particular instance, in order to achieve a 78-foot span, you can see that a minimum of a 22-foot rise is needed. Now, we utilize these types of structures all the time, and engineers do on projects to achieve their necessary clearance. But there are a lot of projects where 22 feet of vertical rise is not available. And so because of that, they may be driven to a different type of solution, which might look like this one, a twin leaf BEBO T-series. You can see here, to achieve 78 feet, you only need 9 foot of rise. But one of the limitations that we see in the BEBO T-series is that in order to make it effectively work on a project, you need very good soil conditions. And that's because of the large horizontal reaction that is developed in these structures. You can see at the bottom of the page here, that horizontal reaction actually is 83 kips per foot. If you've ever tried to design for 83 kips per foot, you either need some very good soil, oftentimes rock is where we see these types of solutions being utilized, or you need a large BEBO block foundation. And so that's a large mass of concrete behind the leg in order to resist those loads. And we do oftentimes do that, and engineers successfully implement it into projects, but that can cause you right-of-way issues as the structure gets larger, and there are a lot of times where the design parameters just don't work. We believe that the twin leaf O-series provides a nice compromise to those 2 items that we just talked about. In order to achieve a 78-foot span in a twin leaf O-series, you need 14 foot 6 inches of vertical rise, which is usually achievable on most projects. And then you also have a horizontal reaction of 34 kips per foot. Now, while that's not a small reaction, it's considerably different than the 80-some kips per foot on the previous slide, and there are a lot of soil conditions and foundation options in order to make a design such as this work. So we are seeing engineers beginning to utilize these technologies in upcoming designs. Here's an example of one of those projects. You see the benefits of a buried structure in this particular instance is that because of the soil around it, there's the ability to plant trees and things over top of the structure and create the aesthetic look that's being considered. This is an option that's being considered along with a multitude of other options on the particular project that's upcoming, but it gives you just a sense as to what clearance boxes and what solutions can be achieved by going to even longer spans via a twin leaf configuration. That's a little bit about some of the new things that are happening, and hopefully Tim can continue to move us along the innovations now with BridgeCore.
Thanks, Scott. Yeah, so let's move on to innovation number 2, which is BridgeCore. And BridgeCore really builds on Contec's long history of designing and manufacturing corrugated aluminum and steel structures. So many of you may be familiar with our traditional 6x2 corrugation pattern. And by contrast, the BridgeCore corrugation is a much more robust 15 by 5.5 deep corrugation. Obviously, that does a whole lot for us. It nearly doubles the structure stiffness, which allows us to have longer spans, higher fills, high live load capacity, all of this while reducing material thickness. From an available shape standpoint, we can do round structures up to a 50-foot diameter. I'm going to show you a case study here in a little bit with a 43, 44-foot diameter whole road grade separation project. And if you ever get out to one of these and stand inside of a 50-foot diameter pipe, it's just spectacular. So there's some real opportunity here with BridgeCore. From an ellipse, again, I have another case study of a project we just finished in Florida that was a custom size ellipse. Single radius arch up to 54-foot spans. Multiple radius arch we can do up to 65-foot custom spans. And then box culverts, we can do aluminum box culverts up to a 45-foot custom span. From an application standpoint, similar to what we talked about with the precast, the same types of applications that we've utilized these structures in the past, whether it be wetlands, whether it be traditional culvert crossings, whether it be mines under heavy loading conditions, we can do those same applications, again, just more efficiently. So let's do a quick design example here so that we can kind of get a sense of some of the savings. What we have here is a wildlife crossing, and this was an actual project that we built utilizing our traditional super span with a 6x2 corrugation. So we wanted to go ahead and put BridgeCore into the equation and see what would that savings have been had BridgeCore been utilized. So kind of working through the design process here, the spans were about the same, 42-foot 3-inch versus 42-foot 7, no big changes there. Rise about the same. End elevation was a little bit bigger with the BridgeCore. But here's where some of the savings start taking place. So from a minimum cover standpoint, the super span required 48 inches. Because of the much more robust deep corrugation pattern associated with BridgeCore, we only needed 30 inches of cover. And here's where the big savings starts. We go from a 1 gauge to a 7 gauge as it relates to the steel, resulting in a reduction in weight from 244,000 pounds to 176,000 pounds. This is also, as we talked about it before, there's an incremental savings associated with trucks and transportation. This resulted in reducing trucks from 6 to 4. So the overall cost savings on this particular project for the installed structure was about 35%. There was a couple other things associated with it. The assembly cost overall was a bit lower, but we also eliminate the thrust beams associated with super span. So if anybody's ever built a super span, when you get up to that haunch area, in order to eliminate any potential deflection, you go ahead and pour some concrete thrust beams along that outside haunch, and that's eliminated with the BridgeCore. It also reduces the amount of monitoring required out on the job site. We've played around with a few of these projects. Obviously, the industry has embraced it. We've got some case studies to work through, but we've seen a savings on average of about 18 to 20% associated with the BridgeCore. Okay, the last thing that I'm going to cover as it relates to our innovations is our express foundations. And I would ask everybody, if we were doing this in front of each other, I would ask, typically why do contractors use precast foundations? Well, usually it's because of speed. That might be a driver, maybe tight working conditions, access, maybe dewatering issues. I mean, those are some of the things that come into play, but typically cost isn't one of them. So what we usually see on about 95% of the jobs we do is contractors just pouring a cast-in-place foundation. Okay, so you get your geotechnical information, you design your foundation, you form it up in the field, You go ahead and set your steel, you tie your steel, and you finish your cast-in-place foundation. And that's what we see in about 95% of the jobs. But there are drivers that result in utilization of precast foundations, historic drivers, as I mentioned. And the early generation of precast foundation were really just sort of blocks of concrete. So again, there's no special science to it. A precast foundation is nothing more than a manufactured version of the cast-in-place design. So if you have a 6x2 cast-in-place foundation, you're going to have a 6x2 precast foundation. Now, those are going to be put on a truck and transported to the job. And like I said, the early generation, it just kind of had blocks of concrete sitting next to each other, and then the arches were set on top. Sort of the second generation had some connector plates. So that was a little bit better. We at Contech, we really like the continuity of a cast-in-place foundation, and we like the connectivity to the native soil. And that's been something we've been working on. It's been a goal of ours for about 10 years to come up with a precast foundation that really mimics all those attributes of a cast-in-place foundation. So sort of the third generation of precast foundations, we're starting to get there. You kind of had block foundations. You'd have a void in the middle, and then you could go ahead and put a closure pour in there to finish out. So you're starting to get that continuity. But you never really had all the aspects of a cast-in-place that we're really looking for, as well as the cost, until now. Express foundations. So what we did with express foundations, we talked to some contractors. We said, hey, what's the cumbersome part of pouring these foundations? They said all the obvious things: forming, setting, tying the steel, and finishing. What's the cheapest part of a cast-in-place foundation? Just pouring your concrete out in the field, right, after everything's formed up. So what we've done is we've put together a blend. Our tagline for Express Foundation is it blends the speed of precast with the economies of cast-in-place. So what you have here is a concrete shell, right? So this is all done at the precast facility, complete with all your longitudinal and transverse steel that is shop applied. So this concrete shell comes out to the job site, and then it's set in place. And remember, we said that the cheapest part of a cast-in-place foundation is just pouring the concrete. So from a construction process, the precast elements or this concrete shell comes out there. All these units are set where you have longer structures where if a precast foundation can't all be shipped on one truck, then obviously you're going to have some joints. You can see here, if you look real closely, this is a joint. So the only work you're going to have to do in the field is to tie a couple of lap bars. But the beauty of these is these units are set. Then your arches are set on top of them. And I don't know if you can tell, if you look here at these express foundations, the void still exists. So we haven't backfilled that concrete yet. So we've eliminated the need to grout underneath that foundation between the foundation, or underneath the units between the unit and the foundation. So all the units are set, then the arches are set, then you go ahead and you backfill your concrete in there, and then you go ahead and, with your wraps and your backfill, etc. So you truly have the continuity of a cast-in-place, the connectivity to the native soil, and a total set-in-place precast structure that now has been driven not just by speed, dewatering, and those type of issues, those drivers we talked about earlier, but truly has been driven by cost. So it's pretty exciting. We certainly see the industry embrace it. One thought on these foundations, just to give you a sense of this whole hybrid blend. A typical 6x2 foundation, again, there's no real typical, it's based on the geotechnical information, but a 6x2 foundation, that shell would represent 27% of the concrete associated with that foundation. 73% would be what we talked about, was the cheapest part of it, that poured in place concrete. And then closing out the loop on express foundations, underneath the wing walls, you really just need a 2x2 leveling block of concrete, if you will. And even the 2x2 is not necessary. So we've developed some precast trapezoidal blocks that are tied into the unit foundation and accept the wing wall foundation on top of it. And we've seen about a 20% material savings over the original rectangular concrete foundation. Okay, so what we're going to do is we're going to now that we've kind of been through all the innovations, we have the Conspan O Series, we have the ongoing O Series innovations, Bridge Core and Express Foundation. Lisa has another poll question regarding utilization. Lisa.
All right, ladies and gentlemen, which innovation are you most likely to utilize in an upcoming design? O Series, Bridge Core, Express Foundations, Twin Leaf O Series, or Multiple Cell O Series? We'd like to get your feedback. And again, we are taking questions, so please don't forget to log those in the question and answer box below. Many responses are coming in. They're coming in quickly, so I'll give a couple more seconds and then close the poll and show the results to everyone. Please get your votes in. Okay. All right, Tim, we have 60% of the audience has said O-Series, 19% has said Express Foundations, 13% Bridge Core, 4% a multiple cell O-Series, and then 3% Twin Leaf O-Series.
That's great. Thanks, Lisa. And you know, that's interesting because we started off on this about a year ago, and we're just seeing the increased utilization of O-Series. But the interesting thing about the Express Foundation is that's really catching on as well. So I've got 4 case studies I'm going to go through and then turn the mic over to Scott, and he's going to do a few more case studies and then close us out. But one of the exciting things about Express Foundation is once somebody uses it. So I'll get to that in a second. This was a project, Central Florida Regional Hospital. There was really 3 drivers, non-impact. There was some high velocities that required some sheeting to prevent scour. And then the installation schedule was such that speed was a necessity. So they utilized precast as a whole, but more importantly, on this particular job, they utilized Express Foundation. So there's a good couple shots there of the project. This is a finished photo of the job just in. This project, we installed this about 6 weeks ago. The hospital just opened. But one of the neat things about this, and the testimonial we recently received, was the contractor who set this particular Express Foundation. He has another job that he's bidding in Florida right now, and that job is not specified precast, not specified express, but he almost demanded that we go ahead and generate some drawings for him so that he can utilize Express Foundation. So I have a feeling that 19% number is certainly going to go up as these structures are embraced throughout the industry. We've talked a lot about the utilization of these Express Foundations for precast projects, but it's really important to note that the Express Foundations are a terrific addition to any of our buried bridge projects. So whether it be precast project, bridge core, aluminum box culvert, it really is an efficient, cost-effective foundation solution. Here you can see utilizing that foundation with one of our plate projects. Okay, in Vigo County, Indiana, there was a need to replace a structurally deficient vertical abutment bridge. Speed was pretty important because they didn't want to have the road down a real long time. The detour was pretty significant. The buses had to go pretty far away from this particular road to detour. So road closure was paramount on this particular project. They utilized Express Foundations, obviously the O-Series, and the result of this project was only 7 days of downtime from closing that road to reopening it, setting this bridge. One thing to point out, this job was complete with precast wing walls, precast head walls, and it had a attached guide rail, a top-mounted guide rail. I know we haven't got into a lot of the technicalities as it relates to guide rails, but sufficient to say we can work with you on guide rails. They can be top-mounted, side-mounted, buried in the fill, etc. We work with designers all the time as it relates to that issue. And then the last project I have, which is really an exciting project, is in Miami, Florida. It's called Northwest 25th Street. This is a huge project consisting of 2,880 feet of 25-foot span, 15-foot rise, custom bridge core horizontal ellipse. It also included 37 riser inlets, 7 laterals, as well as 2 horizontal elbows. Now, one of the challenges of this project was to control, or the project required enclosure of a water control canal. Now, the original design called for some concrete slabs to enclose that water canal. That was incredibly expensive. In fact, this project ended up saving about $1 million in some significant time. It took about a year to put this project in. Probably, we don't know exactly because they didn't end up bidding it that way. It could have been probably 2 years, if you will, if they had to build all that out of concrete slabs. But the way this worked, to control the excavation, sheet pile was driven the entire length of the canal, and then the trench bottom was excavated and graded, and the project included 38 of these 75-foot long bridge core structures. These were assembled in the dry, adjacent to the canal, and then they were set down in the water and backfilled to the crown of the structure. Then the sheeting was removed, the backfill continued to the base of the pavement section. This project just completed, and as I say, it was way ahead of time and saved about $1 million. Pretty exciting bridge core project. Scott?
Yeah, I'd like to just build on some of the successes that Tim indicated there, particularly on the bridge core and the full round structure, or the structure with an invert was an ellipse structure there on Northwest 25th Street. This particular project is at a gold mine in South Dakota. It was for Wharf Resources. And you can see the picture does speak a bit of 1,000 words on this. Those are two 43-foot diameter round structures that were serving as a vehicular underpass with State Highway 473 going over the top. So the mine needed to develop a haul road to be able to get the heavy mining traffic in and out of the mine while not disturbing the roadway up above. And you can see here the benefits of, because it was just a clearance box-driven project, grade separation project, being able to use the full round structure and then filling in the base of those round structures with some fill and being able to drive right through them eliminated the need to put in foundations and was quite a bit of savings for the owner on this particular project. A pretty exciting implementation of a very large diameter structure there. And because of the clearance box being clearance box driven, there really were no hydraulic or other considerations, just made for a unique design. Now this bridge core project is a bit the opposite in that hydraulics was the key driver. This is at the Hotel El Silencio in Costa Rica. It's a 500-acre eco-luxury hotel, and the owner wanted a signature entrance bridge that could make a statement for this property, as well as preserve all of the natural stream through clear spanning and accommodate the hydraulics that come through there in the large rain events in Costa Rica. And so when you look at it, it may look like it's hydraulically oversized. When they get the torrential floods every year in Costa Rica, this structure fills up, and it had to be designed for those large hydraulic events. But a great signature structure there, accentuated by the Keystone headwalls in Costa Rica. Now, as we think about torrential rain, I think, again, a picture speaks a little bit of 1,000 words related to this particular project, which is for the East Valley Water District in Highland, California. And torrential flooding is what was being faced on this particular site. And one of the things that's very interesting is those box culverts there are meant to convey all of that flow up above. And the designers believe that they could have conveyed that flow up above, meaning the open area was large enough. But in this particular instance, the debris blockage that occurs in a multiple cell structure was not taken into account. So there's massive flooding taking place here and almost no flow coming through the box culverts. It's all going over top of the road. And that can be seen here in a little bit of a broader view with the structure there in the middle left center of the screen. And then, of course, after that, you get into all the necessary subsequent cleanup. Well, needless to say, the East Valley Water District determined that a multiple cell structure was no longer appropriate for this location. And so they collaborated with URS and Contech and designed in, as you can see at the bottom of this page, an O-series single cell opening in place of the multiple cell box culvert. And here you can see that single cell O-series going in. One of the unique aspects of the construction in the lower left is that they did saw cut off the existing box culvert and use that foundation, set the O-series right on top, and then you can see the finished photo off to the right. And the last case study I'm going to get into before I wrap things up here is the Kentucky Transportation Cabinet in Clay County, Kentucky, did an inspection of a bridge there and determined that as a result of that inspection, they needed to lower the load limit of the existing box beam bridge to only 3 tons. A 3-ton load limit meant that the school buses in the area needed to route on a very significant detour, about 45 minutes around and away from this bridge in order to get to their locations. So as a result of an initial phone call that we received in April after that construction, we worked with KYTC on some preliminary designs. The project went out to bid in May and then expedited through the manufacturing and installation process, and the construction was complete in September. So as Mike indicated at the beginning of this presentation, accelerated bridge construction is not just the construction, but it's that whole process of implementation and doing things quickly. And you can see how that was able to be achieved here through a 59-foot O-series and a very successful project in Clay County, Kentucky. Now, by my clock, it is 54 minutes past the hour. We understand that we need to finish here on time, and we fully intend to do so. As a result, I think we're going to bypass this particular poll because I do want to highlight just a couple of more things for you. and then we'll wrap up with some instructions about how to get your PDH credits here in just 2 or 3 minutes. But I think it's important for everyone to understand that you see the solutions that we have to offer and some of the examples of how engineers like yourselves are using them. But we do want to be a part of your project really from beginning to end, as much or as little as you would like. In Contech desiring to be your project partner, some of the many ways that we can do so occur through planning and solution development, design support, and then installation. But we found that many engineers like yourselves do like a self-service aspect of some of the things that we have to offer and to be able to go out and start mapping a solution on their own. One of the ways that engineers like yourselves have been able to do that is by logging onto the Contech website and accessing the Design Your Own Bridge or the DYOB tool. That's a tool that is in service for the whole range of Contech solutions, including aluminum box culverts, multi-plate, the precast bridge solutions, as well as truss. And when you log on to that site, what you're going to see is a screen that might look like this, in which you go in and enter some inputs for the project. Typically takes an engineer anywhere from 5 to 15 minutes, depending upon your comfort level with the solutions. And then after inputting that information, and only another 5 or 10 minutes later, you'll receive an email. And that email contains a conceptual design, a conceptual set of plans, which looks something like this. It includes a plan view, a section view, end elevation, and then in the lower right, some sample drawings related to express foundations. The foundations are obviously not site-specific because we need to collect a lot more information, but at least gets the process started in educating your owner and your client about what you might be looking to do on this particular design. The same type of output occurs for aluminum box culvert as well, and you can see that drawing pictured here, the aluminum box culvert plan, section, and elevation, and then the associated express foundation details as well. Now we know that when you're sitting down with a client, sometimes a set of drawings like this alone isn't enough to convey to them what you're attempting to do on the project. And so one of the other things that we can do to assist with those efforts is photo renderings. Here you see an example of a photo rendering in which an engineer has supplied a photo like you see on the left, and then we work with our internal marketing teams here at Contech to develop a photo rendering that looks like the one on the right that you'd be able to share with your client and say, hey, this is about what we're looking to do on the project site. And sometimes that picture is a lot easier to digest maybe than some of the conceptual drawings up above. And then as a project continues to evolve, again, we'll participate in as much or as little of the design as you would like. One of the ways in which we commonly participate is in the foundation design. And that could include just simply supplying vertical and horizontal reactions to any of the types of solutions that you've seen today. And then you as an engineer can go ahead and perform that foundation design. Or the alternative would be we could do the foundation design aspects as well and then simply provide you a set of plans to integrate into your design. Those set of plans come through drawing support, which this is an example of what that drawing support might look like. Would be a full set of what we call contract drawings that are often integrated into a plan set, and then a contractor can use those to actually install and set the structure. So that includes a bridge plan, foundation plan, associated details, and then of course the specifications necessary for backfill and installation. So we hope that what you've taken away from today is a bit of information on the Accelerated Bridge Program, a bit of information on Contech's newest innovations, and we really believe that any of the range of pre-manufactured bridge solutions you've seen here today in combination with Express really embody what the FHWA is after for accelerated bridge construction. So with that, it's going to take another minute or two and wrap us up. As I'm sure you can all appreciate, we have many hundreds of people on the line here today. Doing any type of a question and answer session is very prohibitive, but we do hope you've logged questions throughout the presentation. If you have not, there'll be an opportunity to do so afterwards in the survey. And the biggest question that generally comes up is, how am I able to get my PDH credits as a result of attending this webinar? Upon closing this webinar, what will happen is you will get a pop-up that will come into your web browser. And what you should do is click onto that pop-up, and that will open a link to a survey. By filling out that survey, that allows us to know that you've attended today's webinar, and then gives us the information that we need to follow up and deliver to your PDH credits. The other important aspect of that survey is that we do take the results and the feedback that come from that survey very seriously. We here at Contech want to improve. We want to continue to improve the solutions that we're offering. We want to continue to improve how we deliver information to you. So we would really appreciate your feedback as a result of that. During that survey, you'll have the opportunity to fill in whether you'd like potentially a follow-up presentation in your office or whether you might have a project opportunity and need to speak with someone from Contech. We have a team on standby this afternoon, our bridge consultant team, that services the entire country, and they are awaiting the results of this survey. And should you have any questions, should you have any needs, you could expect to hear from someone in very short order to help answer those questions and be able to do some follow-ups. So with that, I guess I'd just like to thank you for your time here today. We do appreciate that you were able to participate. And again, as you close this out, you'll receive a pop-up in your web browser, and that's how you take the next step to make sure that you're able to receive those PDH credits. Thank you again very much.